So this, unfortunately, brings us to the end of what we have time to teach you in this particular course. We've been able to cover many of the basic concepts in quantum mechanics here, and to confront many of the key conceptual ideas that distinguish our quantum mechanical view of the world from our classical one that we likely grew up with. As I said at the beginning, it's very difficult to teach yourself quantum mechanics. Not so much because the mathematics is hard or because we have to figure out many other things that are different from the classical world, but we have to decide which of our concepts from the classical world we have to throw away and what new ideas we're going to substitute. I think you've now done enough quantum mechanics here to begin to have a serious grasp on what quantum mechanics really is, how it explains the world round about us, how to do some real calculations, and how to construct some meaningful quantum mechanical models. Of course, there's always more quantum mechanics to learn. Based on the knowledge you have now, you should be able to pick up many of the excellent physics quantum mechanics texts and be able to start on a broad range of other quantum mechanical models and examples. In terms of further basic quantum mechanics to help you set up to read a broad range of quantum mechanics literature, including the quantum mechanics used in research in many areas of science and engineering, there are several other topics and useful results that it would be good for us to cover in another course. Specifically, we've not had time to cover the idea of spin in quantum mechanics and the related ideas of what are called identical particles with terms like bosons and fermions, all of which are part of the daily vocabulary and concepts of a working quantum mechanic. For practical applications of quantum mechanics in areas such as the physics of crystalline solids, which underlies all of our modern use of semiconductor materials in electronics, for example, we need some simple but profoundly useful ideas to explain how we understand these materials, such as something called the Bloch theorem, and ideas like band structures and effective masses. If you look at quantum mechanics as it's often written down, you will see that it has used two other notations, one called the density matrix, and the other using objects called creation and annihilation operators. If you're not properly introduced to those, they can look rather abstract or obscure, though in fact both are very useful and in the end not very hard to use. The creation and annihilation operators are actually particularly elegant and fun to work with. Actually, those creation and annihilation operators would get us right back to the topic we started quantum mechanics with, light. That approach gives us a very compact way to examine and write down all of the quantum mechanics of light, and finally, to understand the physics behind those black body curves that started the whole quantum mechanics revolution. So, hopefully, we will manage to see you in a future course where we could cover all of these topics and a few more, and including some of the exciting emerging ideas like quantum computing and quantum encryption. Perhaps also, now that you understand quantum mechanics much better, you'd like to come back to some of those fascinating core philosophical issues about the nature of reality, always a fun topic for some late-night discussions. So, I hope very much that you've enjoyed this exploration of quantum mechanics. I would like to thank you for all of your work on this course and all of your useful feedback. That will greatly improve the experience for future students. To that end, we would also appreciate it very much if you would take a short survey to give us yet more useful feedback. Finally, thank you for staying with us through this course. By taking on the challenging task of trying to understand quantum mechanics, I think you've made a major intellectual step, one that relatively few people on the surface of the planet are prepared to take. And I would like to congratulate you on having the courage and persistence to take it on here. I have to say also that I really do think it's worth the effort. Thank you, folks.